Everything you thought you knew about the ocean's ultimate predator? Complete fiction. 2025 research just detonated decades of scientific consensus. Megalodon wasn't some oversized great white patrolling ancient seas. It was something far more terrifying. An apex hunter that dominated for nearly 20 million years. The largest carnivorous shark in Earth's history, dwarfing even Tyrannosaurus rex. Jaws powerful enough to pulverize a whale skull in one bite. Then it vanished, left behind nothing but hand-sized teeth scattered across the ocean floor and mysteries deep enough to drown in. What killed this nightmare? Could specimens still exist in the abyss, hidden from human eyes? Because here's what'll keep you up tonight. More disturbing than Megalodon surviving somewhere in the deep is discovering we never understood it at all. And the new evidence? We weren't just slightly off. We were catastrophically wrong about its size, its shape, even how it hunted. Megalodon might have been dramatically faster and monumentally bigger than anyone imagined. Let's rewrite history. I'm taking you back to when this colossal predator ruled the planet. We're uncovering the real Megalodon and exposing exactly how scientists got it so spectacularly wrong for so long. Picture an ocean stalked by something triple the size of today's great whites. Jaws wide enough to swallow two full-grown humans standing side by side. Sounds like Hollywood fantasy, right? Except it's not, and the proof started with a bizarre discovery over 350 years ago. 1666. Two fishermen off Italy's coast hauled in a monstrous shark. The locals freaked out so badly that the Duke himself ordered the carcass sent to Niels Stenson, a Danish anatomist working in Florence, better known as Steno. Surprisingly, the shark's size didn't fascinate Steno most. It was the teeth. They looked identical to tungstones, triangular rocks that people since ancient times believed were petrified dragon or serpent tongues. Steno had a different theory. These weren't magical stones. They were ancient shark teeth embedded in rock. He argued that rock layers formed gradually over millennia, and that objects like teeth gave us snapshots of specific moments in deep time. This observation revolutionized paleontology forever. Steno had cracked the code. He discovered what fossils actually were. Cool origin story, but what's the connection to Megalodon? Everything, because sharks lack bones. Their skeletons are cartilage, which decomposes. Their teeth are often the only remains that fossilize, making them our primary evidence. And Megalodon had teeth for days, 276 of them, some stretching 18 centimeters long. Like modern sharks, Megalodon constantly replaced its teeth. Rows were arranged, so whenever one fell out, the tooth behind it shifted forward. A single Megalodon could burn through 40,000 teeth in its lifetime. Translation: over 19 million years, the seafloor became an absolute graveyard of discarded Megalodon teeth. Each one had the potential to fossilize. Those fossilized teeth are basically our entire knowledge base about this colossal shark. We even named it after them. Megalodon literally means big tooth. So to figure out what Megalodon actually was, paleontologists spent decades using these massive teeth to identify its closest living relatives. Megalodon was first formally classified in 1835 by Swiss-born American naturalist Louis Agassiz, who named it Carcharodon megalodon. He placed it in the same genus as modern great whites, Carcharodon carcharias, almost exclusively because the large triangular serrated teeth looked pretty similar. A 1996 skeletal reconstruction led by Mike Gottfried reinforced this. He gave Megalodon the stocky, muscular build of a great white, just scaled up massively. They extrapolated Megalodon's size directly from tooth dimensions. Pretty straightforward, right? Case closed. Giant great white shark confirmed. Hollywood starts casting Jason Statham, and the Meg franchise prints money. Not so fast. Early 2000s research revealed distinct differences in tooth structure. A closer examination of the fossil record suggested something more complicated was happening. During the mid-2000s, Kevin Nyberg and colleagues ran extensive morphometric analyses comparing Megalodon and great white teeth. They found zero overlap in shape variation. None. The serrations on great white teeth were irregular and triangular. Megalodons were finer and rounder. The tooth roots were completely different structures. Translation: it seemed highly unlikely that great whites evolved from Megalodon as originally believed. They came from something else entirely. In 2019, Donna J. used this new evidence to officially reclassify Megalodon within the extinct Odontoceti family, the megatooth sharks. Other members of this family include Otodus obliquus, Megalodon's earliest ancestor that lived during the Eocene epoch, roughly 60 to 37 million years ago. So today, the scientific consensus settles on Ototus megalodon as the proper name, though some researchers still prefer Carcharodon. There's ongoing dental drama in paleontology circles, honestly, but that gives us the basic lineage. Except scientists weren't just wrong about Megalodon's family tree. They were wrong about something even more fundamental. And what's about to be revealed is genuinely disturbing. Every depiction of this prehistoric shark you've seen in movies, documentaries, nightmares is almost certainly wrong, because the largest shark to ever live was actually bigger than we thought. Much, much bigger. For decades, estimates for Megalodon's length were based entirely on fossilized teeth and the occasional rare vertebrae. No complete skeleton has ever been discovered. From that evidence, we calculated its body stretched between 15 and 18 meters maximum. Until now. This year, a team of 28 international scientists, led by paleobiologist Dr. Kenshu Shimada, completely reshaped how the world thinks about this prehistoric titan. Central to this revelation is one exceptionally rare set of vertebrae discovered in Belgium, now housed in the Royal Belgian Institute of Natural Sciences in Brussels. It measures 11 meters long, but that's only the trunk. The head and tail are missing. To fill the gaps, Shimada's team compared it to 165 other living and extinct shark species. This allowed them to extrapolate the animal's true dimensions. They calculated that Megalodon's head likely comprised about 16.6% of its total length, while the tail accounted for roughly 32.6%. Applying this to the Belgian specimen, the shark's total length would have been approximately 16.4 meters, with a 1.8 meter head and 3.6 meter tail. Pretty much aligned with previous estimates. But here's where it gets absolutely wild. There's another fossilized vertebrae from Denmark, 23 centimeters wide. That suggests some individuals may have grown even larger than 16.4 meters, potentially reaching a staggering 24.3 meters, nearly 10 meters longer than we previously believed, rivaling the length of blue whales, weighing an estimated 94 tons. Let that sink in. We underestimated Megalodon's maximum size by nearly 30 feet, but the revelations don't stop there. Megalodon wasn't just bigger, it looked completely different too. While reviewing a 2022 paper where scientists built a digital 3D Megalodon model, Shimada's team noticed the math behind the shark's proportions didn't add up. Using data from 145 living shark species and 20 extinct ones, they built a comprehensive database logging the proportions of heads, bodies, and tails. Then they compared those ratios to Megalodon's known remains. What they discovered changed everything. Megalodon wasn't a stocky, tank-like great white at all. It was far more streamlined. It had a much shorter snout compared to great whites, a flatter, almost compressed jaw, extra long pectoral fins to support its massive weight and size. It looked more like a lemon shark than a great white. The same study revealed something deeply unsettling. Fossilized vertebrae suggest baby megalodons were born enormous, between 3.6 and 3.9 meters long. But that's not the disturbing part. Like modern great whites, they likely practiced intrauterine cannibalism. Embryos ate unfertilized eggs, and possibly each other, to fuel early development inside the womb. Survival of the fittest before they're even born. This new, streamlined, more menacing shape explains why Megalodon could reach that whopping 24.3 meters Shimada's team estimated. Stocky bodies, like the old reconstructions, create massive drag, making efficient movement through water nearly impossible. That's why modern great whites cap out around 7 meters. Any bigger, and they'd lose the speed that makes them dominant predators. The same physics applies to blue whales. They can reach 30 meters because of their sleek hydrodynamic shape, allowing them to traverse thousands of miles of ocean. Megalodon's new lightweight frame also explains why it showed up on every continent except Antarctica. The species was genuinely global. Based on everything we've just covered, Megalodon appears superior to great whites in every conceivable way. Not just unrelated, more refined, fitter, bigger, better. It makes today's fearsome great whites seem almost pathetic by comparison. But don't write off the great white just yet. It's holding one final card, and it's about to deal a fatal blow. So now we finally know what this creature was. How did something so dominant, so powerful, just disappear? What went wrong for Megalodon? We know when Megalodon went extinct because we've only found teeth dating between 20 million and 3.6 million years old. But why it went extinct isn't straightforward. It spent millions of years thriving in the nutrient-rich waters of the Miocene epoch. It had a spectacular run, but all good things end. One recurring theory suggests that as Earth approached the Ice Age, dropping water temperatures became too cold for the giant shark to survive. However, research from scientists Catalina Pimiento and Humberto Ferron suggests otherwise. When analyzing Megalodon's global distribution through time, Pimiento found Megalodon was capable of inhabiting colder latitudes. Its distribution didn't correlate with any known warming or cooling temperature trends. These findings align with Ferran's theory that Megalodon was likely a mesotherm, a warm-blooded animal maintaining body temperature warmer than surrounding water, therefore capable of handling wide temperature ranges. So if climate couldn't kill Megalodon, what did? Pimiento's research showed Megalodon's global abundance peaked in the Middle Miocene, roughly 11.6 to 16 million years ago, before declining. Interestingly, this correlates with massive losses of whales, dolphins, and porpoises, Megalodon's favorite foods. Extinction rates of marine megafauna, the largest species in particular groups, were incredibly high in the Pliocene. Among those lost, 55% of large marine mammals, 43% of sea turtles, 9% of sharks, a total of 36% of large marine species went extinct. Sea level changes may have also impacted Megalodon indirectly. Fluctuations were common during the Pliocene and could have devastated coastal habitats where food was abundant. As all this occurred, Megalodon was forced to compete harder for what remained. With who? The great white shark. After everything, Megalodon's size may have been its downfall. The evolution of great whites, smaller creatures needing less food, meant Megalodon never stood a chance. A deep-sea David versus Goliath story. So how is it that 3.6 million years after extinction, there are eyewitness accounts and documentaries claiming it's still out there? Could Megalodon really be hiding in the ocean's darkest depths? Is it possible it's lurking in the Mariana Trench waiting to reveal itself? For a moment, they almost had us. One of the most notorious Megalodon is alive conspiracies was a 2013 documentary investigating the shark's continued existence. Watched by millions, it was admittedly compelling. It showed a blue whale carcass off Hawaii that appeared brutally attacked. A scientist explained the culprit had to be Megalodon-sized. Other scenes claimed to show 6-foot fins near similar whale attacks. Unfortunately, or fortunately, depending on your perspective, many viewers missed the disclaimer stating the documentary wasn't based on fact. The entire thing was fabricated. Faked photos, staged footage, actors hired to portray scientists. There have been other unconfirmed sightings. In 1918, fishermen off Australia's eastern coast claimed to see a shark 31 to 95 meters long stealing lobster pots. As recently as 2022, NBC Boston ran the headline, 2 Megalodon sightings off New England. Spoiler, it was a basking shark. Another common argument points to large animals like giant squid taking decades to be scientifically documented. However, their remains washed ashore and were caught by fishermen for ages, giving us hard evidence they existed before we'd seen live specimens. By far the most common argument, we've only explored 5% of the oceans. While technically true, we don't need to explore everything to know a giant whale-killing shark isn't down there. Megalodon was an apex predator. If they still existed, orcas and great whites would never have claimed their throne. It's no coincidence that around the time Megalodon went extinct, whale sizes exploded. Without large predators like Megalodon, Pleistocene whales were twice the size of Pliocene whales, hence the appearance of blue whales. But I've saved the best theory for last. What if Megalodon's just hiding in the Mariana Trench? A theory popularized by Jason Statham's film, The Meg. That story was based on actual Megalodon teeth discovered near the trench by HMS Challenger in 1873. They appeared unusually white and fresh, dated between 24,000 and 11,000 years old. The reality's much different. Those pearly whites were just uniquely well preserved by a thick mineral crust of manganese dioxide that significantly reduced decomposition rates. Not recent at all. There are other problems. If we've learned anything, it's that Megalodon needs to eat a lot. The Mariana Trench doesn't have enough food to sustain a 24-meter megashark. Snailfish are the deepest dwelling fish, but we don't find them until beyond 8,000 meters, possibly for the same reason there isn't enough to eat, and they're only 20 centimeters long. So there we have it. Our journey back to the true age of giants, and one of the most magnificently monstrous beings ever to exist, comes to an almost anticlimactic end. Something so mysterious and powerful feels like it deserves to exit among fireworks and explosions. Instead, the reality is rather quiet. Despite that, Megalodon remains endlessly intriguing. It seems fitting that something so elusive kept a 19-million-year secret. Yes, Megalodon is definitely extinct, but its mystery lives on. There's just one way to know for certain what Megalodon was, and like any good mystery, they've still never found a complete body. So until then, giant lemon shark it is.